Today I'll be demonstrating the use of motion analysis software to analyze a soccer ball kick. So first, MATLAB is the programming language used. VirtualLab script is opened, and then the F5 key is hit to run the program. Starting with the video edit portion, select the file to be imported, and we must change the file input format to be all files so the video shows up. Once that's selected, the video will play in its full length. Now we must trim the video to analyze the frames directly before and after the impact. The looks of the video, we see we can choose frames 480 through about 520. And that will give us all the point tracking information we'll need. Accept and save. This then saves the video as a separate file, and it's helpful to name it accordingly. We'll again replay the video several times to make sure the right frames are being set. Now moving on, we'll move to the dynamics portion of VirtualLab. First, we'll select the input video file that we just trimmed, and we'll have to enter the frame rate. In this case, it's 480. Then we will use some known parameters such as the ball size, and also we'll have to physically measure the size on the screen with the cursor. One click starts the vector, double click ends the vector. We'll do this 3 times. And key in the actual size of the object. Next, moving on to point tracking, we'll define several points of interest. You can select up to 4 points. In this case, we're selecting the foot, the knee, and the ball. Selecting the point and tracking function runs a separate MATLAB function which analyzes the initial and final positions. A slight glitch loses the video. But now we'll define the different vectors that it will output. First, the vector from the knee to the foot, and then from the foot to the ball. Next, we select boxes, point, and vector so that the program outputs Excel data on both the pixels and the associated vectors that we chose. Now pay attention to the boxes and the different colors. These are color coordinated in the Excel file to tell you which objects is associated with each color. I didn't like it the first time, so I had to do it again. Now, it shows each of the points of interest and the associated vectors. In this case, we're interested in the final ball velocity. accepting and saving it to another file name, which shows the tracking vectors and boxes around each. Then we'll hit data saving, which exports all data into an Excel file, which can be used for analysis. Pay close attention to the meter pixel ratio, which will need to be multiplied by each of the columns highlighted to get the actual distance in meters. Right now it's in pixels.